Okay, our last rule for triangles that we're going to see in Chapter 5 has to do with the possible lengths of the sides of a triangle in order to even be able to construct a triangle at all. So, for example, I'm gonna go to my graph paper to hopefully give you a picture of this, since we, if we're not in person, to be able to see, specifically what we mean by this. But suppose I have a segment of length 2, and I draw it along here, and then I'm going to draw a segment, another segment of length 2 this way. So of course we have a right triangle, but it really doesn't matter if I had a right triangle or not. I could, situate the segments this way, on angles. It really doesn't matter, but there's a maximum length for what this third side could be, right? I can't just pick any length side. Now, there's also a minimum length, but suppose I had a side of length, let's say 6, just to exaggerate. There's no way I can possibly make a triangle with that segment. If the segment length is 6, you're not going to make a triangle. And if I try to stretch these two sides out, even if I make the angle like 180 degrees, the maximum length, so if I go to a 180 degree angle, which would give me no triangle, okay? If that's 180 degrees, that means we have no triangle, right? And that would be a length of 4. 2 plus 2 would be 4. So if I take one of these sides and start to turn it in just a little bit, so maybe we have a really big angle, and we just turn the side that way a little bit, and it still goes out too. Well, now I can start to form a triangle, but the length of that side would have to be less than 4. I have to bring the endpoints, I have to bring these 2 points here and here a little bit closer together in order to be able to form a triangle at all. So if the two segments are length 2 each, then that third side can't be any more than 4. If it's bigger than 4, we won't be able to construct a triangle. So it has to be less than 4. But then there's also a minimum amount for that side of that triangle. If I bring these two sides closer and closer together, the side would have to be at least bigger than 0. We can't have anything smaller than that. But if I had two sides of length 2 and bring them really, really close together, then we can start to form a triangle. So we have this triangle inequality that comes from that very concept that states if I take any two sides of the triangle, in particular just take the two smaller sides, I have to add them together and they have to be bigger than the third side. Okay, so if the three sides don't work in this way, then I don't have any kind of triangle at all. So the first kind of exercise we want to do is just look at 3 possible sides and determine yes or no, would they equal a triangle. So the quick way to do this is you identify the two smallest sides. I take 3 plus 4. And then I show that that's going to have to be greater than 6. So 7 is greater than 6. So this is going to be possible. Okay, you can possibly sketch a triangle with those two sides, right? Or 3 sides, 3, 4, and 6 would make a triangle because the two smaller sides add up to be longer than that third side. Now in the next one, I have 6 plus 9. I need that again to be greater than 15. And you're going to see that it's not greater than 15. When I add 6 and 9, I get 15, and that equals 15. So this would be not possible. All right? What would happen in that case? 6 plus 9 would equal 15, and you have a 180-degree angle, and you would not have a third side. You need to bring that closer together, and that third side would have to be a little bit less than 15 in order to make it possible. This will be an equilateral triangle. That's always going to be possible. If all 3 are the same, then that means any two sides are going to add up to be bigger than the third side, right? 8 plus 8 is greater than the third side, 8. Okay. In this case, we have 2 plus 4, the two smaller sides. Is that greater than 5? And it is. 6 is greater than 5, so this would be possible. Okay. We can make a triangle with those 3 sides. In this case here, we have 4 plus 8, the two smaller sides. We need that to be greater than 16. 12 is less than 16, so this is not possible. And the last one, we have a couple of decimals, so I need 1.5 plus 2.5. I'm going to need that to be greater than 3. And when I add 1.5 and 2.5, I get 4, which is greater than 3. So this combination would be possible. We could construct a triangle with those 3 sides. And now we're going to ask a different type of question. We want to know what's the smallest possible side that a side could be, and what's the largest that it could be. So there's a shortcut way of getting to this. So in other words, let's just say 1 and 6 are the two smallest sides, okay? 1 plus 6 is 7, okay? So when I add the two of those together, I need this third side to be less than that. Remember, when I add the two smaller sides together, they have to be bigger than whatever the third side is. If I have a third side that's bigger than those other two sides, and again, I'll exaggerate it. Suppose I have a side of 1 and a side of 1, okay? The third side has to be smaller than 2. Okay, if it's not smaller than 2, then we won't be able to create a triangle. So the way I got that was adding those two together. Now we go the other direction. Suppose 6 is the biggest side. If 6 is the biggest side, then when I add 1 plus this other number, it needs to be bigger than 6. So if we pretend to think that 6 is the biggest side, then we would say 6 minus 1 is 5. So this other side has to be bigger than 5. It cannot equal it. It's going to have to be bigger than it, right? Because 5 plus 1 would equal 6, and that would be no triangle. So I need this side to be a little bit bigger than 5. Right? So that might be a little confusing at first here, but hopefully what you notice is that we're doing two things every time. We're subtracting the two numbers, and we're adding the two numbers. So I take 18 minus 12 is 6. So supposing the two smaller sides are 6 and 12, 18 is the biggest side. Then if I'm a little bit bigger than 6, like 6.1, then 12 plus 6.1 would be 18.1, and that's going to be possible. And then the second thing I do is I add 18 and 12, supposing that 18 is the biggest side. So 18 plus 12 is 30. So this third side has to be less than 30. If I add 18 and 12, they have to add up to be bigger than the third side. And we know 18 plus 12 maxes out at 30. So the third side would have to be less than 30. Okay, so 2 steps each time. We subtract the two numbers to find the lower limit, and we add the two numbers to find the upper value for the side of that triangle. Let's try a couple more examples. I would take 5.5 minus 1.5. Oops. And that's 4. So the third side has to be bigger than 4. And then if I take 5.5 plus 1.5, that's going to be 7. Third side has to be bigger than 7. Okay. Last one, we have two numbers that are really far apart. 82 minus 8 puts me at 74. So this third side would have to be greater than 74, so that when I add 8 to it, it's going to be bigger than 82, in case 82 is the biggest side. And then we take 82 plus 8. That maxes out at 90, so our third side cannot be bigger than 90. It would have to be a little bit smaller than 90. Okay, suppose you have 3 different positive numbers arranged in order from least to greatest. So let's just make some numbers up. Let's do that a few times. 2, 5, and let's say we have 8. Right? Let's say we have 3, 4, and 9. Right? What single comparison will let you see if the numbers can be the lengths of the sides of the triangle? And we started the whole lesson with this. I would take the sum of the two smaller numbers. Right? I would look at 2 plus 5 and ask, is that bigger than 8? Okay, I would need that to be larger than 8. I would take 3 plus 4, and I need that to be bigger than 9. So the single comparison would be to add the two smaller numbers and compare that sum to the largest number. So we take the two smaller numbers, add them together, and we compare that sum to the largest number. That's the single comparison. Always take the two smallest if we have all 3 sides. Now, if we only have 2 sides and we're trying to decide on the possible values of the third, we subtract them and we add them, and those are the endpoints of our interval.